Voice clear? Audio okay? And full board visible? Confirm two things. One is full board. I'd make slightly down, I think. 1 minute. Slightly down because it is slightly upper side. Now? Yes, now full okay. Why no reply? Audio okay? Clear? If you don't reply, I can't start. Then I have to wait for some time. Color problem. Which is blue color here? You have not answered still. Voice clear? I have asked 4 or 5 times. Already 10 minutes over. No comment came. I asked voice clear, no reply. If there is no reply, nothing means class has to be closed. Repeatedly ask. Okay, this much time for answering. Okay, now, see, come to last part here. You have to make a note. Those who are serious should make a note. Heading. See, can anywhere, you write somewhere here, heading, you write here. Full board visible, first of all. What I wrote, everything visible. Okay. Make a note here. Heading, you write wherever you want. See, I dictated heading. Write somewhere here. Cantilevers where from free end up to some distance, up to some distance. That some distance I will take L0. I will tell you why I take symbol L0. Reason. Up to, this is not span. Up to some distance, say L0. L0 from free end, not fixed end. See, suppose you apply a point load here, don't tell this distance, this side. From free end up to some distance, say L0. There is no load or couple. That is, for example, see, if this is the beam, left side fixed I will take. See, some loading is here, any loading. It can be UDL or point load, couple, anything. See, this is your L0. Nothing from here to here. Then tell how the elastic curve will come right here. That is, like either this way, you can write either this way, you can tell, or, see, or somewhere here. Either that way or I will put here. Or this way. See. Some load here. Any type of load. See, this is your L0. Then from fixed end up to here, it will bend. You take anything. Wherever you apply point load. See, if I take cantilever fixed here, apply a point load, from fixed end up to there, curvature will be there. Then, see, there will be elastic curve here. It will come like this. See, blue color, elastic curve. Here, see, here. The elastic curve will come like this, up to here. Okay, then, there will be slope and deflection here. Then, from then onwards, what will happen, tell me? From then onwards, up to, see, very important, from free end up to some point, that point I will call Q, some common name Q. This also I will call Q. So you can write from free end, don't by heart A, B, C, D. From free end up to some distance L0, say up to a point Q, some distance L0 or up to a point Q, point say Q. There is no load, nothing, fully free, nothing is there. Then this side they will be loading, load, couple, anything. Then when the beam bends from fixed end, there will be what? Elastic curve coming this way. Here, elastic curve like this. Okay, now, once you reach here, then onwards, tell how is elastic curve? You can tell straight, see here. If I apply load in the free end, see, full beam curvature. Now, if I apply load somewhere here, from this side, see, any load apply here, see here, this will bend. The remaining portion will not bend. Why will not bend? Two reasons are there. First reason, practically you can make out, see, this way. That will be straight, not linear. It will be straight. It will be like a rigid member. See, it will be straight. No curvature, straight. Second reason, from here up to here, wherever you see, tell the bending moment. For that length L0, tell the bending moment. What is the bending moment? Anywhere for the length L0. You should write all these things. For that length L0, what is the bending moment? Anywhere. Look that side. How much bending moment? Wherever is the bending moment. How much bending moment? No, what is the bending moment from here up to here or from here up to here? Bending moment. See, no answer. What is the bending moment means you are not answering. For that unloaded length L0, that's why not symbol. What is the bending moment? Anywhere. Whether here or here, anywhere in that portion. How much bending moment? By not answering, doubt comes to me, whether clear or not. And you are already wasting lot of time. Then I need one more class. If this much delayed to comment, that's why I told more people should come to the class. Not selected few, all seeing the recording. See, if this much difficulty to tell what is the bending moment from here to here, anywhere, bending moment. Okay. Why B, why A it is. I will change. I have not gone there first of all. I have not gone there. I will correct it later. See, first of all, I have not told anything here. You have not answered the question. What is the bending moment for that length L0? Don't know what to do. Zero after so much of time. Bending moment is zero. See, you know that M by I equal to E by R. Therefore, your curvature 1 by R equal to M by EI. When M is 0, your curvature becomes 0 or radius of curvature becomes infinity. Curvature 0 or radius of curvature infinity means what? It means radius of curvature 0, curvature 0, this I told you earlier, or radius of curvature infinity means what? What is the meaning? Radius infinity means what? No, radius infinity means what? It is possible only for what? Radius is infinity. If curvature is there, there is a radius. So when radius is infinity, or it is almost Allah. It is straight. It is not almost straight. It is straight. Why almost straight? Why that word almost straight? It is straight. No bending, nothing. Self weight not considered. Some will tell self-weight. Self-weight, if it is there, I tell you. It is straight. So this portion will remain straight. How it will be straight? Not, is it randomly this way? Tell me. Is it randomly straight this way? Or some pattern is there? You cannot put randomly straight. See, this also straight. This also straight. This also straight. How to decide which one? It can be straight like this, or straight like this, or straight like this. How to decide which case? That also, practically you can see here. How straight you can see. How to decide? No. What you do is, here, see, draw a tangent to elastic curve. Okay, then the remaining portion will be straight along the tangent, or this straight line portion itself is tangent to elastic curve. So this itself is, if I extend, the straight line portion itself is tangent to elastic curve at this point. Clear? How the deformed shape this way. If you extend it, that itself is tangent to elastic curve at this point Q. Make a note. Clear? Yes. Therefore, now to see how to find slope and deflection here, and also or here. See, here also tangent required. Okay, this way. How to find slope and deflection here? Very simple. See, now come to exaggeration. Big sketch. A, B. Do not by heart AB. A left hand fixed. Right hand, sometime exam they can give A, B, C. Do not by heart A, B, C. Okay. Fixed here, free here. Load stops here. L0 length, no load. Here. L0 length, no load. Then bending is there. See, now. So, A to Q will behave like a cantilever. This is the span. See, for this cantilever, see, this is the span for cantilever. Cantilever AQ. This is the span for the cantilever AQ. Here, this is span for cantilever BQ. BQ. Correct? This is a cantilever. Don't see this one. You imagine this is cut out. Cut it. Throw it outside. So this is a cantilever. Now, L0, not because 0, no curvature. 0 stands for no curvature length. L0 length, no curvature. So therefore, this is deflection at Q. This is theta at Q. Okay, now, when you reach here, see, if this is deflection at Q, this is, see, even if there is no curvature, this point, this will come down, this will come further down. Why? See, when you apply load here, how much this comes down, that will come further down because of the turning. Therefore, see, this is deflection at free end. Don't remember, deflection at free end. For both the cases, here YB, here YA. What you can do is, if you want deflection at free end, see, it is, but you can say equal to what? The deflection at free end equal to deflection at Q for both the cases. See, deflection at free end equal to deflection at Q. Here also, see, both the cases. Deflection at Q plus what? Plus additional displacement due to what? Tell me. Additional displacement due to what? I want that one. Additional displacement due to what? Additional displacement due to. It is not the displacement which will cause pain. See, if you take a hand finger, apply a load, pain will come. There, that extra deflection, no pain, nothing. Due to theta, rotation. Additional deflection due to theta at Q. See, because of theta at Q. Now, see this triangle. see this triangle or this triangle. For both the triangles, tan theta q equal to, see, this y naught. That initial deflection symbol is y naught. Y naught. So both the cases, y naught. So y naught divided by L naught. See, tan theta equal to y naught by L naught. But we always take tan theta equal to theta. Therefore, theta equal to y naught by L naught, or directly you can tell what? Directly you can tell y naught equal to whatever is y naught equal to whatever theta, whatever is theta q into further length. Therefore, lastly, I will tell by words now whether cantilever is this way or cantilever is from that side. Does not matter. From the free end up to some distance, say L naught, say a point called Q, here called Q. When you do a problem, it is not Q, some other name will be there. Up to a particular point Q, there is nothing, no load, nothing. Full beam will be zero. So that will remain straight, no curvature. Then the deflection at the free end equal to whatever is the deflection at the Q point Q, that is where loading starts, plus rotation at that point into subsequent length L naught up to free end. Okay, up to anywhere, up to L naught, both the cases. Now, therefore, the total deflection is this already yq plus y naught. Now tell me, and what is the theta at the free end? Tell me. Theta, see, from here to here, it is a straight line. So this is final deflection. See, this is deflection at the free end equal to, I told. This is a formula for deflection at the free end equal to. Tell me, lastly, what is, this is y naught. What is theta at the free end? Theta at free end. First answer. See, this is straight line. For a straight line, slope will remain constant. Theta at the free end equal to theta at Q only. See, when you reach here, up to here, slope will keep on changing. Then, from here to here, so I put a tick mark here. See, this one and this one are equal. This one and this one are equal. This theta equal to this theta equal to that theta, both are same. And deflection extra equal to this cantilever deflection by formula or anything, plus extra deflection because of the rotation. So I will tell lastly now without seeing there. See, this you write in words. Cantilever beam, any side fixed, don't bother left side, right side. It can be this way fixed, left and this way, or it can be this way. What you do is, from the free end up to some distance, say L naught, we reach a point, say Q. That point name will change later. Now derivation or basic principle Q. No load, nothing. Then that L naught length will have no curvature. It will be straight this way. It will be straight, but what? Not horizontal. It will tilt here. Therefore, see, now there will be some deflection and slope at the point Q. At the starting of that L naught, see, at the starting of the L naught from fixed end side, or where the load, where unloaded portion, where it starts here, at the point Q, there will be slope and deflection. That you have to find like a cantilever. And span is only this much. Now, you get slope and deflection here. Then, if you want to find slope and deflection at the free end, you don't have to find the slope. Whatever slope came at the end point there, before the what? Straight line starts, that itself is the slope at the free end. Because by inclined line, For a straight line, only one slope. But deflection at the free end equal to whatever deflection you got at that point Q, where curvature stops, that deflection plus extra deflection equal to that theta into unloaded length L naught. Full clear? If clear, I will go to example now. If full clear, I will start example. That's all. Very powerful for competitive examinations. Full clear. Okay. Now I will start examples. And make a note. Instead of this one, you can use moment area method also. I will solve both. See, you can use moment area method also for this one. Your choice. It is not that you should use formula. We will do by both. Okay, start. One by one question. I will start one by one in correct order. All are important for objective question in examination. That is competitive exam. Remember, this type of question comes for not only GATE and engineering service. This can come for your PGCET or PWD or any competitive examination of jobs. Why? It is very simple. These people will ask complicated question. Usually they ask for GATE or engineering services. See, question number 1. New question. I won't put number. Question here. There is a cantilever beam which is fixed at the left end. Okay, I will put here. Cantilever beam which is fixed at the left end. Okay. Length of the cantilever is, I will take bookwork question, L. Okay, then see, there is a couple, clockwise couple M at north side. Usually they give center. Center I will not give because why? If center, these two are equal. Let it not be equal. M at L by 3 from the free end. So this point I will call A, this point I will call B, this point I will call C. That Q is gone. Over. Question is, find slope and deflection at, they can ask at C and also at B. B means what? At C and B. Remember, question is not C and B. Question is right there. Find slope and deflection at the point of the couple and also at the free end. That is for us theta C y C. Okay, start solving. Two options. See, somewhere here I will go for moment area method. Here moment area. Okay. First I will go for moment area method. See, draw the beam. Because why? Let us get the answer first. This is the beam. Moment area method, you don't bother about what? You don't bother about the curvature, etc. Nothing. You know the formula. Okay. Couple M. This is A. This is B. This is C. This is L by 3. This is 2L by 3. Okay, now this is M. Don't see this formula. Draw the bending moment diagram. Bending moment here, 0. Up to here, anywhere, bending moment 0. The moment you come inside, bending moment is M. See, here. This side, 0. But when you come inside, M. Then anywhere you see, it is constant M. This is the bending moment diagram. Sign not required. Distance is here. Okay, now, that's all. Tell the answer now. I told you repeatedly what is the formula for cantilever. I will not write. See, if you want theta anywhere, area of the BMD from that point up to fixed end. If you want deflection anywhere, moment of the area of BM by EI diagram from that point up to fixed end, about that point. I will not tell again and again. Start. Directly, theta C equal to area from C to A, 2L by 3 into M. Why? I should now at least start to give some work for you. Now also if you expect me to write all these things, then what you are doing all these days? shouted class after class, over. You write here, those who want to understand, write theta C equal to area of the BM by EI diagram from C up to fixed end A, over, by EI. Answer is 2 by 3 ML by EI, over. Then deflection at C required. Moment of the area of BM by EI diagram from the C point up to fixed end. This area about C equal to area 2L by 3 into M is the area into center of gravity from here is half of 2L by 3. Half of 2L by 3 divided by EI. And tell the answer. It will come some number into ML square by EI. Tell the number. Number. 2 cancels. 2 cancels. 3 into 3 is 9. 2 by 9, huh? Is it 2 by 9? Tell me. Is it 2 by 9? 2 by 9. Okay. Now, next. Over. Slope at B required. Slope at B. Area of the BM by EI diagram from B up to fixed end. From here to here. Oh, there is no area. From here to here means this area only. Why? There is nothing here. So, 2L by 3 into M divided by EI equal to 2 by 3 ML by EI. Same as this one. Then, deflection at B. Moment of the area of the BM by EI diagram from B up to A. That is this full area. But moment about B. So, area is 2 by 3L into M is the area into moment about B. How much? L by 3 plus from here to here is half of 2L by 3 or by EI. Tell the answer. How much? Number. This also will come in terms of ML square by EI will come. Number. What is the number? That number. 2 by 3 into bracket 1 by 3 plus 1 by 3. 4 by 9? Okay. It is 4 by 9 ML square by EI, over. Question is solved by moment area method. I think examination, they will ask any one of them within 15, 20 or 30 seconds, you can do it. Okay, now come to what? Our shortcut method. Okay. Now this side I will go for shortcut. This side is my shortcut here. See, shortcut this side. Start. This is the like a big sketch here. See, examination little neatly. Put the beam here. Little big sketch, not this much sketch. Put a big sketch. From A up to C, you show solid line. See, solid line. Because there is a couple here, M. After C up to B, there is nothing. Do one thing, put dotted line. So A, B, C. This way right. Distance right, because why? It is not, I am putting a big sketch here. So this is 2L by 3. This is L by 3. See, remember, this is that point Q now. Okay, now, below put elastic curve. Dotted line here, see. I will use blue color for the curvature. Up to where curvature is there, I will use blue color. Blue color, black is. Okay. I will use blue color where curvature is there. Or I will use red color to make more clear. Red is better, so you can see from there. I will use red color for curvature. Why? Clearly visible. Because very clearly visible. From A up to C, beam will bend with the curvature. See, up to C. Stop. Then you draw a tangent here. Continue that line. That is the straight line portion up to here. Now, This is your, how? Clockwise, this is also clockwise. This is your theta C, this is theta C. And this is your YC. And this is your final Y at B. Y at B. Don't put it. This is theta C, this is theta B. Actually both. These two are equal, remember. And somewhere here, right, project here. See, this is the extra distance, that is Y naught. Okay, now everything substitute there only, here only. YC equal to a cantilever of length 2L by 3. This is the cantilever. I'll make red color. Where curve, see, this is a cantilever. This, now see the formula there. Cantilever of length L. Now length is 2L by 3. So this YC equal to M into, what is formula? ML square by 2EI. L is 2L by 3. M into 2L by 3 square divided by 2EI. And slope equal to, right somewhere here, equal to M into slope at the free end, ML by EI. M into L is 2L by 3 by EI. Why? Length is, this is the span. Okay. This answer is 2 square is 4. It is 2 by 9. 2 by 9 ML square by EI. This is 2 by 3 ML by EI. Now, this Y naught equal to whatever is your theta C multiplied by subsequent distance. How much? L. See, Y is this extra distance equal to whatever slope here into this distance into how much? L by 3 or equal to that extra equal to theta C is 2 by 3 ML by EI into L by 3 equal to 2 ML square by 9 EI over. Okay, now write the answer one by one. Start. What they want? They want theta C. Theta C equal to, answer is ready here, 2 by 3 ML by EI. ML by EI if you want clockwise. That you know it. Then they want deflection at C. See the answer here. Deflection at C equal to 2 by 9 ML square by EI. Down. Then they want theta B. Oh, your theta B is same as theta C. Same as theta C. Don't see there. Both are equal. How much? 2 by 3 ML by EI. Clockwise. Then you want deflection at B. Free end deflection. Deflection at B equal to whatever is the deflection at C plus that extra Y naught. Deflection at C is 2 by 9 ML square by EI plus extra deflection is once again 2 by 9 ML square by EI equal to 4 by 9 ML square by EI down. Check the answer with the moment area method. Tallying or not tallying. Check the result with the moment area. Comment fast. Tallying or not tallying. Check the answer with the moment area. Comment tally. Because you wasted lot of time in the beginning. 10 minutes you wasted for replying. Whether I think you all of you came late. Otherwise, I thought today I will finish everything. Now I need one more class for this one. Just comment. Tallying or not tallying, I want. I explained maximum possible. More than that, you cannot find anybody explaining. See, just to give one answer. Answer tallying or not tallying, you are taking that much time. Compare the two results by moment area method and also by the shortcut method. No answer, no reply, nothing. Someone should tell. You compare the two answers. I am asking because I want to confirm that voice is clear. My purpose of asking and waiting is not time pass. Suppose some audio problem is there. what I am going to talk further is wasted. So that's why once in a while I ask clear or like that. It is tallying only. How it will not tally in my class? ನೋಡಿ, ಇನ್ನೂ ಆನ್ಸರ್ ಇಲ್ಲ ಎಂದು. Tallying or not tallying, still no answer. I asked it 10 times now. ನೋಡಿ, 10 ಬಾರಿ ಕೇಳಿದೆ ನಾನು, ಇಲ್ಲ, ರಿಪ್ಲೈ ಇಲ್ಲ, ನೋ ರಿಪ್ಲೈ. Something should be done for this one. That much lag is not there. That much lag is. See, I am only hearing my voice. Little lag only. It looks like as if the voice will take hours together to reach you. Illa. No, this is called very bad response. Not answering the question. After 10 minutes you will tell clear or tallying. It's okay. Why this much time you are wasting? My purpose of asking tallying or not tallying is not for time pass or to show that in my class it tallies. In my class it will always tally. No problem exists in the world where what? Different value will come. But my purpose is to ensure that audio there is no problem. Suppose later I find out that audio is not clear or gone for remaining time. What I talked here is wasted. So I want once in a while confirmation. Okay. Second question. See, now I will give a homework for you. Homework. Workout. A cantilever beam fixed here. I will apply a couple here. 100 kilonewton meter. This is 2 meter. This is 4 meter. Over. This is A. This is B. This is C. Remember now? Now this is the cantilever. Okay, now what I want is, I want slope at B, I want deflection at B, I want slope at A and deflection at A. All are something divided by EI. Slopes are in radian, deflections are in meter. You try and solve, I will give the answer for you. Try later. 100, 400, 400 ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಬೇಕಾ ಇದಕ್ಕೆ? 400, ಇದು 400, 400. 402 is 400, 800. 800 plus 800, 1600 ಆಯಿತು. ಕರೆಕ್ಟಾ? Yes, correct. Over. That is the answer. Try it. See, if I am writing examination, see how fast I give the answer. Don't worry, I will not come and give competition to you. Okay, now go to next question. Next question is a point load. See, very important now. Objective question point of view, this is the most important question. A cantilever beam, see, I will go numerical now. WL, I will give homework for you. Beam of length 6 meter is loaded by a point load of 90 kilonewton at distance of 2.4 meter from the free end. This is A, this is B, this is C. Find slope at C, deflection at C, slope at B and deflection at B. Or words, cantilever beam of length 6 meter loaded by a point load of 90 kilonewton at 2.4 meter from the free end. Find slope and deflection under the load and also at free end. I will work out this question. Now, one homework for you. Reverse. Cantilever this type, a point load here P. This is L by 4. Span is L. This is A, this is B, this is C. They want theta, they want theta C, they want deflection at C, they want slope at A and deflection at A. This is homework for you. I will give the answer and rub it out. You try later. Slope 9 by 32 PL square by EI. Deflection 9 by 64 PL cube by EI. If wrong, I'll correct it. Let me know. Slope at A is same. 9 by 32 PL square by EI. Deflection here. (27 by 128 PL cube by EI. By chance wrong, you tell me in the comment box. Immediately in the comment box, I replace my correct answer. By chance, you see, this is not technical mistake. Suppose by chance, you will tell, sir, it is not 9 by 64, it is 9 by 32. I am careful. Then in the comment box, you have to tell, don't put other comment. The value is given, I am getting so and so. I will immediately take the calculator, check it, and in the comment only I will write, yes, corrected answer is so and so. Principle will not be wrong. Over. Now, that question I am removing. You solve it by both methods. One solved by moment area method, one solved by shortcut method. Okay, start here. This question I require, see, theta C, Y C, theta B, Y B. I remove this one now. Okay. Now, here I will do moment area. Why? I first prefer moment area first. Why? See, if you use moment area, so easy. See now. This is a beam. Point load is here. How much? 90 kilonewton. This distance is 2.4 meter. If that is 2.4 meter, total 6 meter, this will be 3.6 meter. This is A, this is B, this is C. Draw the bending moment diagram. 0, 0, here 90 into 3.6. That all you should make. Side is not required. 324 is the BM ordinate here. Now it is a straight line. See, couple means constant. Now triangle will come. Okay. A, B, C. Now start. I want theta C equal to area of the BM by EI diagram between C and A, this area, half into 3.6 into 324 by EI. Okay, answer will come. I want deflection at C. Moment of the area of BM by EI diagram between where you want deflection and fixed end. Again triangle. About this point. Half into 3.6 into 324 is the area. Moment about this point. So it is here. This is into 2 by 3 of 3.6 by EI. Answer. Then I want slope at B. Exam they will ask only one of them. If you want slope at B, area of the BM by EI diagram from B up to fixed end A. From B to A means there is no diagram here. Once again this area. Half into 3.6 into 324 by EI. Answer. Lastly, deflection at B. Moment of the area of the BM by EI diagram between B and A from here to here. About B. So, but area is only here. Half into 3.6 into 324 is the area into moment about B means what? 2.4 extra plus another from here to here is 2/3 of 3.6 by EI. You get the answer. Okay. This is moment area method. Half into 3.6 into 324. 583.2 by EI radian clockwise. All you write. I have better work to do. What is 583.2 into 2 by 3 of 3.6. 1399.68 by EI. Here, once again, 583.2 by EI. This is 2799.36 by EI. Slopes are in radian, deflections are in meter, direction, see elastic curve. Okay, over. Now, come to shortcut. Leave it now. That is the, I think some people will tell, sir, moment area is much better. Tell yes or no. Moment area is much better. Tell yes or no. Tell yes or no. Actually, moment area is much better. Some will tell that way. Yes, if you know the concept, yes, you can use moment area. But anyway, everybody cannot understand moment area. Come here. Here. See. Now, this cantilever beam, I use red color. This is the cantilever with a point load of 90 here. This is the cantilever, red color. This span is 3.6 meter. To understand, this is A, this is C, red color. From here onwards, it is B. This unloaded length is 2.4 meter. Okay, now, somewhere here, draw elastic curve. Up to here, it will have curvature. Okay. Then, draw a tangent here. It will go straight up to here. See, now, this is your deflection at C. You get it by cantilever formula. This is your theta C, get from cantilever formula. Now, this is your extra, if I draw tangent here, if that is theta C, this is theta B, both are same. Then, this is your Y naught. And this is your deflection Y at B. See, from here to here, Y at B. Start. First, theta C, slope here, cantilever beam of span 3.6, don't see here, point load 90, span 3.6. See the formula there, slope, WL square by 2EI. You write if you want. So, your theta C will be W. Formula you can write from there. I won't waste time. You, those who are serious, write the formula WL square, but L is not 6 meter. This is your L, red color only. 90 into 3.6 square divided by 2EI. That answer is 583.2 by EI. 583.2 by EI. And deflection at C equal to, see here, cantilever deflection WL cube by 3EI. W is 90 into L is red color, 3.6 cube divided by 3EI. 1399.68 by EI. Now, theta B equal to theta C only. And this Y naught equal to whatever is your theta C into subsequent length into 2.4. Theta C is already known for you. Where is it? 583.2 into 2.4. Calculate. 1399.68 by EI. Okay, now, therefore, answer theta C equal to 583.2 by EI. Deflection at C equal to 1399.68 by EI meter. I won't waste time. Theta B is same as theta C. Both are equal. 583.2 by EI. Deflection at the free end, that is maximum deflection, is whatever is deflection YC plus extra deflection Y naught. Add it. 1399.68 plus 13, both are equal. Huh? How it is same? 1399.68. It is coming coincidence, both are equal. 2799, it is a coincidence. Don't tell that way it will come equal. I don't know, it is a coincidence. It will not happen next time. 232799.6 by EI. Do not by heart that way. Both are coming equal. It came equal by chance. Now, fully clear and answer tallying. Fully clear and answer tallying. Fast tell me. Full, clear, and also answer tallying. Fast. Full, clear, and also answer tallying. Yes. Okay, now I will go to next case. See. Okay, this I will remove. There is a cantilever beam. See, there is a cantilever beam. Homework I given. One side fixed, one side free. Okay, I will take fixed here. Red color is better. It's a cantilever. There is a UDL here. UDL is for a length of 5 meters. Unloaded length is 3 meters. ABC. UDL is 30 kilonewton per meter. See, over. Find slope and deflection at the end point of UDL C at C, and also slope and deflection at the free end. That is the maximum slope and maximum deflection. This you have to calculate. Okay. Now, simultaneously, I will give homework for you from this side. I will give UDL here. This length is only 1 meter. This is 2 meter. Okay. UDL 1 beta. 1 quarter easy I think. This is 1.5 meter. This is 2 meter. UDL is 60 kilonewton per meter. A, B. This time I will do one thing now. I will call B here, A, B, C. Okay, now see, they want theta B, they want YB, they want theta A, and they want YA. I will give the answer, homework, work out that one. Theta B. AT by EI. Theta A also 80 by EI. $120 by EI. $240 by EI. Here also comes equal. I don't know why comes equal. Better. 240 by EI. Okay. Take homework and work out. Solve by both the methods. Moment area method, and remember, when you do moment area method, your BMD will come this way. From here, free end. That much you can make out. If you want to understand, you should make out. Okay, start. Now, this question. First, I will solve by moment area. Why? Best method, moment area. See, this is the cantilever beam. This is here, see. There is a UDL of 30 kilonewton per meter. This loaded length is 5 meter. This is 3 meter. A, this is B, this is C. Draw the bending moment diagram. Bending moment here, 0. Here also 0. Here bending moment is 30 into 5 into 5 by 2. If you cannot get that one, you better not continue my class. After all this explanation, if you cannot get that BM ordinate, better not attend my class. Why? I don't want to put further comment. See, 0 here, it is a parabolic variation, second degree. Remember now, for this area is 1 by 3 base into height. CG is at 1/4 from here and 3/4 from here. Told repeatedly for you. That's all. Okay, start. Now, they want theta C. Area of BM by EI diagram between C and A. How much? 1/3 of 5 into 375 by EI over. They want deflection at C. Deflection at C is moment of the area of the BM by EI diagram between C and A about C. So 1 by 3 of 5 into 375 is the area into its center of gravity is here. We want deflection here into this distance, that is 3 by 4 of 5. Then they want slope at B. Don't wait again. Slope at B equal to area of the BM by A diagram between B and A. That is, there is nothing there. So once again same area. 1 by 3 of 5 into 375 by EI. They want deflection at B. Moment of the area of the BM by A diagram from the B free end up to fixed end, this full area, moment about B. So area is 1/3 of 5 into 375 is the area into moment about B. From here to here is 3 meter plus another 3/4 of 5. 3/4 of 5 equal to. That is 1 by 3 of 5 into 375. 625 by EI. This also 625 by EI. 2343.75 by EI. 4218.75 by EI over. That is solution by moment area method. Okay, now come to shortcut. Shortcut. This side. What you do? You draw a cantilever from here, from A up to C is loaded. See, UDL of 30 kilonewton per meter. The length of that cantilever is 5 meter. This is A, this is C. Remaining portion is unloaded. So elastic curve will go. This will bend like this here. So this is your deflection at C, and draw a tangent here. This is your theta C. Then this will be a straight line remaining portion. So if I continue here, this will be, if I come to free end here, this will be the extra deflection Y0. This is the final deflection Y at B. Over. Start. One by one. First, theta C. Slope for a cantilever of span 5 meter with UDL. Formula. WL cube by 6EI. W. 30 into, you can do one thing. Calculate here only. Here only. 30 into 6 cube by 6 30 into 5 cube by 6EI. 30 into 5 cube by 6EI. 625 by EI. And remember now, this is your theta B, same as theta C. Okay, 625 by EI. Deflection at C. Deflection at the free end of a cantilever of 5 meter. WL power 4 by 8 EI. 30 into 5 power 4 by 8 EI. 2313.75. Or 2343. Because I am seeing different answer there. 2343.75 by EI. And this extra deflection Y0 equal to whatever is your theta C into subsequent distance of 3. Unloaded length is 3. This will come 625 into 3. 1875 by EI. Now answer. Theta C equal to 625 by EI. Even later, theta B also same, 625 by EI. deflection at C is 2343.75 by EI. Deflection at B is whatever deflection at C, this deflection plus extra deflection Y naught. So to 2343.75 add 1875 4218.75 by EI. Tell the answer. Every fully clear and all the values are tallying. Fully clear and all the values are tallying. All are tallying or not? Not only just clear, it should tally also. What we got by moment area, fully clear and all tallying. Okay, now over. Further. See, be little careful now. See. Next question, important. There is a cantilever beam. There is a cantilever beam of span for 5 meters. There is a load of 60 kilonewton at 3 meters from fixed end. This is an exam question given. ABC. ABC. And question is, what upward load is required at B? What upward load is required at B so that deflection at B equal to 0. Deflection at B equal to 0. That's the question. They are asking you what upward load is required at B so that deflection at B is 0. That's the question. See. Now, solve by moment area. Moment area. That's all. See, now there is a downward load of 60 kilonewton here. This is 3 meters. This is 2 meters. That's all. Draw bending moment diagram. 0 here, 0 here. 16 to 3 is 180. It will come like this. Remember now, this is hogging beam. Because of this beam, the beam will deflect like this. Clear? The beam will deflect like this. Now, consider the extra load here. Separately you have to do it. Let it be P. Let it be P at free end. Now the bending moment diagram is 0 here and P here. It is P into 5. 5 times P. Straight line BMD. This will sag the beam, or due to this one, deflection is down. But here, if I draw elastic curve, beam will deflect up here. See, this I will call deflection at B for first case. This I will call deflection at B for second case. Now, for zero deflection at B, tell me, your Y at B1 down should be equal to YB2 up. Clear? How much this will push it down, that much should be the upward deflection here. Clear now? When you apply 60 kN, B will come down. When you apply P, B will go up. This is an examination question given for recently one competitive examination. Question clear? They are asking you what is the value of P. Okay, now do one thing. Find downward deflection here. Find downward deflection here. What is the formula? By using deflection, moment of the area of the BM by EI diagram between these 2 points. These 2 points, about this point is half into what? 3 into 180 into moment about this point. 2 plus 2 by 3 of 3. Moment about this point is the downward deflection. This should be equal to the upward deflection is moment of this area. How much? Half into span. Span is 5 into 5p is the bending moment arm into 2 by 3 of full length 5. By equate these two, you get the value of P in kilonewton. Answer. You will get the value of P in kilonewton. Tell fast P in kilonewton. Tell the value of P in kilonewton. No, tell the value of P in kilonewton. First, what is the P? Equate those two. This is an objective question given. Answer P. Fast. Then I will tell you something. I will tell you something then. You don't bother. You tell the value of P, I will tell you something. .92 kilonewton. Okay. Now, if this question is given to me, I will tell you what I will do. See, I will do one thing. I will put a support here so that that point will not move. Then that support reaction itself is P. Tell yes or no. I will put a support there so that you don't try these things all. Not possible for you. I will put a support there so that the support reaction upward itself is P. Tell me yes or no. This is all asking for trouble. Don't try these things. Nobody should try these things. Asking for too much. This level, I am not, you are not capable. But danger. Such thinking called danger. Clear? I will put a support there so that the support reaction there itself is yes. Now, this will become statically indeterminate beam. I will first calculate this moment here. That moment equal to 60 into 3 into 2 square plus 30 into 2 into 3 square divided by 5 square. That moment will come 50.4. I analyzed a propped cantilever by force method. Now, due to 50.4 divided by 5 will give downward reaction there, then plus the reaction, then plus y equal to, then minus 60 into 3 divided by 5 is my reaction. I got reaction of 25.92 kilonewton. Tell me, answer, I am not seeing your answer. Answer tallying or not tallying. Answer tallying or not. I honestly got 25.92 kilonewton. I got the proper reaction. Answer tallying. See, some will tell, from where you went there. From here, I went somewhere else and came back. I got 25.92. But it is advisable not to try these things unless you got perfect grip on the subject. Okay, leave it now. What I told is only for those who think, this person is coming by hurting, or nobody will think that way. Then I will tell them, I will show the real talent here. Talent means not that way. How much deep you can go. Okay, leave it now. Now, come here. This question. Now, you apply a force P here. This you have to do now. Danger, see. I use a red color now, P. I use a blue color. I use a blue color load, P. Now you have to solve it. After writing everything, I will take a break. You should solve. Time ge blue bartha. I will apply a force P here. Okay, now, here also. See now, correctly consider. First you consider a cantilever beam. From A up to C, there is a point load. 60 kilonewton load. This is 3 meter. Remaining portion will be straight, no bending. So your elastic curve will be, how elastic curve? The elastic curve will be, it will go this way, then it will come this way. Okay, start. Now, you find what is this deflection. this deflection equal to 60 into formula 3 square by 2 EI. This slope equal to 60 into what? 3 square by 2 EI. Now, this deflection, now when you reach here, extra deflection is, this is how much? This is 60 into 3 square by 2 EI is 270 by EI. This slope is, that also is 270. Both are equal. Why? 60 into 3 cube. Where I am? See, 60 into 3 cube by 3 EI. So deflection, 60 into 3 cube by 3 EI. 60 into 3 cube divided by 3 is 540 by EI. This is 60 into 3 square by 2 EI. 270 by EI. And this extra deflection equal to 270 by EI into subsequent length of 2 meter. I am not putting symbol now. Into 2 is 500, 270 into 2. 540 by EI. Therefore, because of the 60 kilonewton, deflection at B will be equal to 540, equal to this 540, both are equal, some other reason. 540 by EI is this deflection plus extra deflection of 540 by EI. I don't know why it's coming same. 1080 by EI meter down. Now I will apply cantilever with only upward load P here. Beam will deflect full like this. This deflection is P into full span 5 cube by 3 EI. Now this deflection downward, this deflection upward, you equate these two. Why? How much this comes down, that much this will take up. Equate those two. Tell the value of P fast. 1080. Tell the value of P fast. Tell the value of P. How much? This is my shortcut. How much P? Moment area give 25.92. When I analyzed a prop cantilever, there also I got 25.92. When I got shortcut, what is the answer? Answer. Once again, 25.92. See, to do different solution, you should have confidence. If confidence is not there, you should not try. Why? If answer is not tallying, you are in trouble then. Okay. Now clear? Now, shortcut for cantilever, one triangle load pending. Okay. I will take tomorrow because why? One triangle load pending, time already 9, approaching 9 o'clock now. I should stop. I got class. I will take tomorrow, and then tomorrow I will do a special question. See, sometime for cantilever, there will be change of EI. This I will do last one. So tomorrow's class is the last class for shortcut for cantilever. Okay. Tomorrow we will close this chapter. Further, so many questions are there. I cannot do there. Here limited. At least this much useful. Tomorrow I will do that UVL problem, and then lastly, non-prismatic, when change of EI is there. Okay. Thank you.